Hey guys, today we're talking about proportional relationships. Let's look at a situation. Ms. Cochran is planning a year-end pizza party for her students. So she finds this place that charges $8 for each medium pizza. They don't charge delivery though, so we don't have to worry about that. So every pizza costs $8. So let's look at the chart and complete the table. If we have 1, 2, 3, 4, or 8 pizzas, go ahead and see if you can fill them in for me. Okay, so here's what I have. For 2 pizzas, it would be $16, $3.24, $4.32, and for 8, we can't just add 8. This one we actually have to think about. 8 times 8 is 64. So for each number of pizzas, write the relationship of the cost of the number of pizzas as a ratio. And remember, we always do money over items when we're writing these. So in this case, let's write a ratio for each one of these. So what do we notice about each of these ratios? If we simplify them, they all become $8 over 1. So what does that mean? That means that the cost per pizza is always going to be $8. So they're all the same ratios. So when we write that, they all simplify to $8 per pizza. This is what we call a proportional relationship. The two quantities are proportional if they have a constant ratio, which is what those fractions that we just created, those unit rates were, 8 over 1. For the relationship in which this ratio is not constant, then they are non-proportional. So if it's got a constant ratio, it's proportional. Let's look at another example. Andrew's going to earn $18 per hour mowing lawns. Is this amount proportional to the number of hours that he spends mowing? So let's write out our ratios. For example, he makes $18 for 1 hour, $36 for 2 hours, and so on and so forth. Simplify the ratios and let's see what he makes per hour and if it's constant. So if we divide each of our earnings by our number of hours, we're making $18 an hour. So this is actually a constant ratio. As we can see, it's increasing $18 per hour. So this is a proportional relationship. So let's write that as our conclusion statement. Andrew's going to make $18 per hour, and $18 over 1 is a constant ratio, so it's proportional. Okay, let's see if you can do this one on your own. Go ahead and pause the video, and I'll be back in just a second to show you what I did. Okay, so Uptown Tickets charges $7 per baseball game, plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets? Okay, so let's think about this. If we buy no tickets and we just say, hey, can you just process my order? You're going to pay $3. If you buy 1 ticket, you're going to pay $10. If you buy 2 tickets, you're going to pay $17. And if you buy 31 tickets, you're going to pay, if you buy 31 tickets, if you buy 3 tickets, you're going to pay $24. I don't even know where I got that. Okay, so let's look at these as proportions. This right here, this processing fee, is going to mess up our proportion. For example, if we do 10 over 1, 17 over 2, and 24 over 3, this one is $10 for 1 ticket, $8.50 for 1 ticket, and $8 for 1 ticket. This $3 processing fee, which I don't expect you to have in your table, that's just in my explanation, is going to cause this to not be a proportion. So for this one, we write not a proportion. Okay? And why is it not a proportion? Because there's not a constant rate. Okay, so which of these tables represents a proportional relationship? Okay, so let's look as we go. If we simplify this, 2 hours for 8 miles, and we go through it, How many miles are we going in 1 hour? Well, that would be 4. So go ahead and see if all of these are going to be a constant ratio. All right, so I'll show you what I did. Make sure that you tried it on your own first, though. So when simplified, all of these simplify to 4 miles for 1 hour. So this one's a proportional relationship. Go ahead and see if you think B is a proportional relationship. Okay, here's what I did for B. The only two here that have common ratios are this one and this one. The rest have all different. So this is not a proportional relationship. Let's look at this one. The tables shown represent the number of pages Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? Go ahead and try this one. Determine yourself which one is the proportion and not the proportion. I'll be back in just a second to show you what I did. Okay, in this one, I determined that this is a proportion because they all simplify to 2/5. Or excuse me, not 2/5, 5 over 2. Because if we look here, the time is always 5 minutes over 2. This one could simplify to 5 over 2. This one, and this one. Over here, though, for Gabe's, this is not a proportion. So this one is, this one's not, because over here, if I simplified this and I divided, this one would be 5 and 2, if I divided by 2. This one, if I simplified it, 12 divided by 5 is 2.4. So if we look here, all three of these ratios are not the same. Another way to see these quantities is via a graph. So if we look at these graphs, the way that we tell if it's a proportion is we have to look at the y-axis and the x-axis, their ordered pairs or their points, and where it crosses the axis. Okay, so if we look here, the point of origin is the middle of the graph. The y-axis is the one that goes up and down or vertical, and the x-axis is the one that goes along the horizon. It's the horizontal axis. If we look at a point, the x-coordinate is number 1. It's the first coordinate that we see in the ordered pair, and the y-coordinate is the second point that we see in the ordered pair. So this coordinate allows us to walk along the x-axis first, and then we rise the y-coordinate. So let's look at an example like on James, and he is earning $5 babysitting. So if he earns $5 an hour babysitting, determine whether the amount of money that he earns is proportional to the number of hours that he babysits by graphing on the coordinate plane. Oop, that's supposed to say plane, not place. Explain our reasoning. So let's look at the table. He's going to earn in 1 hour $5. So in 2 hours, he would earn 10, and in 3 hours, he would earn 15. If we graph this, would it start at 0? The answer is yes, because if he doesn't work at all, he won't earn any money. So if we create a table, we would start by having our time increasing by 1 and our money increasing by 5. So at 0, he makes no money, but then at 1 hour, 5, 2, 10, 3, 15, and so on and so forth. So this goes through the point of the origin, or 0, 0, and it increases at a constant rate. These are the two requirements of it on a graph. It has to start at 0, 0 in our table and in our graph. So if we look back to our tables like this one, if we went back 5 each time, let me erase this work right here. If we went and it went back 5 each time, it eventually would get to 0, right? This one goes back 2 each time and it eventually gets to 0. So when he started, he had read no pages. And if we look here at this table and this graph, it has to pass through the origin and increase at a constant rate. Let's look at another example. The cost of running a video game. Go ahead and try this one and I'll be back to show you the answer. The first thing that I did was create my graph with my axes labeled. Now I'm going to plot my point. If you notice here, if we go back to 0, it starts at 1. So this is not a proportion. While it has a constant rate, it's still not proportional because it doesn't pass through the origin. If we look at this one, the table shows the calories versus the minutes of exercise. And as we increase, do you notice that this should actually be a 12? If it was proportional, it would be increasing by 4, but it's actually increasing slightly more rapid. So the reason why this one won't work is not because it doesn't pass through the origin, but because it's not a constant rate. So there are 2 requirements. So just by looking, which one of these is not a proportion? In your notebook, I want you to write the line, and we'll talk about it tomorrow. That's all I've got for you today. See you next time.